All right, good afternoon, everyone. Today is Monday, October the 11th. This is the 12:30 p.m. session of day 2 of Ellipses. We've got a bell work problem on the board. Hopefully all of you had time to finish it. So let's quickly go through it because day 2 of Ellipses is kind of long. Let's see. The center is -1, 2, it looks like. The A value should be 3. The B value should be 2. Ooh, and then the, let's see if I need to do this in my head. 9 plus 4, what is it? Square root of 13? You all agree with that? Square root of 13. All right, so this one is longer in the y direction, it looks. I'm just gonna do a little ellipse like that, just so I can keep everything straight. So that means the vertices should only change in the y direction. So my x center is -1. So we're gonna have 2 plus 3 is 5. And then we're gonna have 2 minus 3 is -1. All right, y'all agree with those vertices? Okay. All right, vertices for the minor axis. Well, it's smaller in the x direction, so we're going to change the x value. So we are going to have, I'm kind of running out of room, so I'm just going to draw a little arrow here, pointing out to these. So we have -1, -2, and -1 plus 2. So -1 minus 2 is -3. The y value doesn't change. And then the other coordinates, we're going to have -1 plus 2 gives us a +1, 2. All right, those look good to you? Yep, looks good. Okay, good. And then our focal points, our foci, those are going to change in the y direction. So that means we are going to have -1, 2 plus radical 13 as the first one, and then -1, 2 minus rad 13. All right, those look good. Just kind of speeding through these. And then the major axis length is 2a, so 2 times 3 is 6. So that's going to be 6 units. And then our minor length is going to be 2 times 2 gives us 4. All right, everything look good? All right, so I didn't show a whole lot of work or really much of any work just because I want to get through this problem pretty quick. But I did show this. That's really important. For whatever reason, I need to see this. It really helps me kind of keep everything straight when I kind of run through these in my head. But easily make a mistake if you do what I just did and try to do everything in your head. Please show your work. All right, let's get into day 2, which is right equations of ellipses. Okay. Paper, pencil, Desmos, GeoGebra. All right, this is just recapping. This is nothing new. This is from day 1. Just shows the 2 equations of ellipses and the little diagram that goes along with it. Same thing for this page. This is from day 1 of ellipses. So I'm gonna skip past this. Same thing. So to write our equation of an ellipse, we need these things. We need the center of the ellipse. We need to know the A value, the B value, and we also need to know if our ellipse is elongated horizontally or vertically. So if we have these 4 things, we could write the ellipse rather easy. All right, so here are the first 4 problems, and you're given some information. And some of these problems, the information they give you is just makes it really easy to create the the equation. And sometimes, like maybe number 4, if you're just given endpoints, maybe it's not as clear. So you really have to understand the parts of an ellipse and use what they give you to kind of figure out, this is a puzzle. We're trying to figure these missing pieces. And drawing a picture or even using Desmos or GeoGebra to kind of plot what we know that's given to us and kind of go from there. Because every problem is going to be different. It's not going to be the same every single time. So let's look at this. Number 1, I'll give you a chance to write this down, but I'm just going to read it. This one says, you are given that the major axis is horizontal. You are given the center is -4, -8. The major axis is 12 units long. The minor axis is 4 units long. And please, again, I know I say this a lot, but if you come to the live sessions, make sure you're actually going to participate and be here and take your notes. There's no reason to be in a live session unless you're going to do that, because you can always watch the recording later. Plus, if you just log in and then you don't do anything, and I do the polling to see who's done it, who's not done it. If you're just not here, then you're just holding up the entire class. Not fair to everyone else. But everyone should have written this one down. And ideas on this problem here. Or what can we do? We can draw a sketch, sure. All right, so I like what Rachel said. She, we know the center. So let me just kind of go to this page. I do have some things written out here, but we do know the center, right? So I'm obviously writing down what's already given to us, and we know that our equation of ellipse is going to be some x stuff squared plus some y stuff squared equals 1. So this is the standard form of an ellipse. So we can at least do this, and we can even put like something squared and something squared. We do know the coordinates. So like what Rachel said in chat, we can at least fill that in. So go ahead and write that. So hey, look, our equation is almost done. So all we got to figure out are the a and the b value. All right. Now, given this information, do we know if our ellipse is elongated horizontally or vertically? Do we know that? So it's horizontal, and it actually says that the major axis is horizontal. So that tells us it's longer in the x direction horizontally. So let's go ahead and draw an ellipse, just to show that, just a picture. So if it's longer in the x direction, is the a going to be under the x, or is the a going to be under the y? Yeah, it's going to be under the x. So I'm going to go ahead and just put an a, just like earlier this morning, and then I'll put a b under here. And that just helps me keep track of which one should be bigger. So we know the a value is always bigger than the b value. We also know the major axis is 12 units long and the minor is 4 units long. So what is that? How does that help us? So Rachel says 12 equals 2a. So then what does a equal? So then a is 6. Yeah. So remember, from vertice to vertice, that is the length. So that means from here to here, it tells us that that's a length of 12, right? So that means from the center to one of them is half of the length. And remember that, so that's your A value, right? So that is A. And then from, here to one of these vertices, that's your B value. And we know that from, the what's given here, the minor length is 4 units. So that means half of 4, like it's like some of you gave me yeah. So what, some of you already said it, that the B value is going to be 2 because it's half of the length. So the B value is 2. So creating like a little rough sketch like this and kind of labeling stuff will help us possibly solve this. But we can see that the A value is 6 and the B value is 2. Right. So yeah, there's the math, and like we could have set up a little different. Like some of you said in chat, we know that 2a is equal to 12, and we know that 2b is equal to 4, and that may have been a little easier than just jumping right into half of 12 is 6, half of 4 is 2. Creating that formula, because remember, 2a is the entire length, 2b is the entire minor length. So that one was pretty easy, right? And then we have to simplify. So that one is very easy. They're not all going to be this easy. They get, like, the problems I have set up for the next 3, they get progressively more difficult. And I give you a little bit less information, or some information that you just got to do a little bit more work to kind of figure it out. Oh, did I have a typo on here somewhere? Oh, I did. I I mistyped it. Whoops. Yeah, I typed these yesterday. Obviously, I made a typing mistake. And you didn't see that. And there's bound to be other typing mistakes on here. Hopefully, I don't make that many. Let me go ahead and fix this on my PowerPoint. So I fixed mine. All right, everything looks good now, I hope. Yeah, it looks good, I think. Oh, it should be. Oh, did I? Oh, and it should be a plus, not a minus. Yikes. Okay. Hopefully, that's the only mistake I have on this PowerPoint. Just like quickly looking at to see if I did that mistake anywhere else. It looks like I didn't, so hopefully that's the only one. And see, this is why I don't like your TGAs typed, because things like that happen all the time, and I have to mark them wrong. Like if I graded this and I saw your final answer, you changed it, I'd mark it wrong. All right, let's go to number 2. All right, let me. I'm gonna give all of you, let's say, 2 minutes to see if you can figure this out. When you do finish this problem, give me a green check so I know you're done. And if everyone's done within 2 minutes, we'll just go on. All right, time is up. Give me an X, so at least I know you're here. All right. Okay, everyone's done. Good. All right. So let's start with what number goes here? A -2. Yep. What number goes here? +7. All right, so let's go ahead and fill those in. Yeah, those are given to us, so that's nice. Right. What number goes here? So what number squared? So what's that number? So is it 2? So is it 2 squared that goes there? Yeah, okay. 2 squared. All right, and then what goes in the other blank? 14. So it would be 14 squared. All right, do all of you agree with that before we actually write the final answer? All right, looks like not everyone is here. All right, guys, make sure you're paying attention, please. Let's kind of run through it. So we all know the center is, well, it's given to us. So yeah, that I agree with that. Does this ellipse says the axis is vertical, the major axis is vertical, so that means it's longer up and down. Okay, and then so that means the a value should be under the y stuff. So I'm just going to put an a here, and I'll put a b here. And it says the major length is 28. So from here to here, that's 28. So half of 28. So from here to here, that's going to be 14. And then, same thing for here. So from here to here is 4. So half of 4 is 2. So that means that A is 14 and B is 2. All right, so I'm just running through my thought process here. And then we just use 2 squared and 14 squared for the final answer. So there's kind of my thinking here, but again, you can think of it as 2a is equal to 28, and then you solve. I think I'm going to change my my PowerPoint to kind of reflect this. That way, we actually use the formula, and then 2b is equal to 4. Then you would solve. So I kind of like that better. All right. So not too bad. That was pretty much similar, if not the same as the previous one, right? Yeah, that was pretty much the same, just it flip-flopped which one was the major axis. All right, so let's go into number 3. All right, a little different. I gave you different information. The center 0, 4, the height is 18, the width is 20. So with that information, I'm going to give all of you, we'll say 3 minutes. We'll say 3.5 minutes. I don't think 3 is going to be enough for just learning how to do these. So 3.5, ready to go. Draw a picture. So whatever you're given, based on this, try to draw some rough sketch. It doesn't have to be exact. You don't have to put it on in Desmos. You don't have to put 0, 4, but draw a picture to kind of reflect what's going on. Just like that previous example, I went through and I labeled stuff as I saw it, kind of help us create the equation. When you finish this problem, just give me a green check. When everyone's done, we'll just go on. All right, so it looks like everyone's finished. Let's go ahead and see what we got here. All right. So what's underneath this blue box right there? A 0. So a plus or minus 0. So I put it in the form of x minus h and then y minus k, but it doesn't matter. Like you can probably skip this right here or even put plus 0. All right, what number goes underneath this blue box? Minus 4. Okay, I agree. All right, what did you find this number right here to be? A 10? Somebody says a 9, so it's either a 10 or a 9. Anybody else? We got 2 people say 10, 1 person says 9. But all of you are finished. So if all of you are finished, it'd be nice to have all of you respond to see what you got. 2 say 10, 1 say 9. We got another 10. Anybody else? 3 for 10, 1 for 9. Nobody else, huh? All right, we got somebody changed their answer to a 10. So some of you, all of you are finished, but not everyone wants to type in chat. Come on, don't be afraid. All right, we'll go with the majority. Yes, it is 10, which means that other one is a 9. We simplify it, right? So that is your final answer. Nobody should put x plus 0 or x minus 0 for your final answer. If you stopped right here and you wrote that as your final answer for the numerator, it is wrong. This is not simplified. Make sure that you rewrite this as, well, just x squared. This is your simplified solution. All right, so let's talk about this one. Based on this, the height is 18, the width is 20. Is it longer horizontally or vertically? Yeah, horizontally. And we know that because, well, the width is longer than the height, so that's pretty clear. And then from here, we can just label it, right? So the width is 20 and the height is 18. So we can set this up as 2a is equal to 20, and we can say 2b is equal to 18, and then solve them accordingly to get our a and b value. Also, we know that is longer in the x direction horizontally. So if it's longer in the x direction, that is where the a value is going to be, and this is where the b value is going to be. So I think it really helps to kind of label stuff as we go so we don't make mistakes. And then really we have everything we need. We know the center. And then here's just from the diagram, you can just take the 20 divided by 2 and get 10, and take the 18 divided by 2 and get 9. But using the formulas, this is what you would want to create, and then you want to solve them to solve for a and b, which you would get 10 and 9, of course. So also, this problem wasn't too bad. So let's look at number 4 here. Ooh, let me So another 3.5 minutes. Again, when you finish, I'll have the polling up. You give me a green check. This one might take a little bit longer to kind of figure out, but again, use what you have to see if you can figure anything out. All right, I'll give you 3.5 minutes. Yeah, when you finish, just give me a green check. I'm just waiting for one more of you. All right, so let's see what we got. What did you get for the x piece here? -5? Okay, let's put -5 there. What about the other blank? Y what? Y plus or minus what number? Y plus 8? Okay. And then let's go for the final answer. So what number after you square it goes here? 36. Okay. And then what's the other number? 4. Okay, so a lot of 4s. So let me just check my answer real quick. Let's see. I disagree with that answer. But my answer could be wrong. You know, I did type this last night. It is very possible I am wrong. But let's go through this. So the part that I disagree on all of you is I have these two numbers switched. I have a 4 here and I have a 36 here. But again, I could be wrong. Let's see if how I think right now is the same as I thought yesterday. So we all agree with the center. We all agree that the center is this. How did all of you find that coordinate? And there's a few ways I can think of doing it. The midpoint of the major axis. So the midpoint of the major axis. Yeah. So you could have done the midpoint of the major axis, or you could have done the midpoint of the minor axis. It doesn't matter which one you do, right? As long as you do the midpoint. You know, one thing that I noticed here is, you know, let's put these coordinates. So, you know, we don't really know if it's longer in the X or Y direction quite yet. But I'm trying to think of a way we could probably show our work without actually knowing that yet. Maybe doing the lengths. So between the point, let's do that first. So looking at these major and minor axis, you probably want to find the distance between these 2 points to see if from this point to this point versus from this point to this point. So when you calculated the distance from these 2 points, these two versus these two, what was the length of well, it tells us the major axis. What was the length of that major axis? It was 12. Yeah. And so these are changing. If you notice, see how this is 5 comma -2, this is 5 -14. It says it's the major axis. The y values are the ones that are changing. Did anyone catch that? And it was like a giveaway that it was the major is the y axis. Let me see that. Yeah, so endpoints of the major axis are these. So, and the y values are the ones that are changing between these 2 points. So I'm just going to put, a y. I'm going to put a y. Oops, that's not my pen. I'll just put a y right here, and then that means that I'll put an x right here. And I did that because, again, the major axis, actually, I won't put it there. I will put it, I'm trying to think of a good place that would make, you know, if I was a student, you were a student, and where would it make the most sense? Maybe right above it, maybe put a y here and then put an x here. And I'll just box this. So the major axis is your y direction, and the minor axis is the x direction. And we know that again because between these 2 points, it's the y coordinate, the y value is what's changing. So from -2 to -14. So we're going up and down for the major axis, it tells us. So that is the y direction. And then for the minor axis, between these 2 points, the y value stay the same. It's the x value. So going left and right is where we're going to be going between those 2 points. So that tells us the minor is the x. Does that make sense? Looking at it like that? Okay, now it is possible that this problem could have been a little harder, and maybe I just gave you endpoints of one of the axis lengths is these two, and an endpoint of another axis is these 2 points. And then it would be a mystery if it was major or minor, and then you would actually have to find the distance between them. I heard one of my dogs crying. Oh, I see. All right. So I gave you enough information where we don't actually have to calculate the distance per se, at least not yet, to determine which one's bigger, because I'm telling you that it's bigger in the y direction and it's bigger in the x direction based on this observation. So I'm going to just draw a sketch of an ellipse showing that it's bigger in the y direction, just for fun, right? Also, we could do the midpoint of the major or minor to get the center, but based on the fact that these are the 4 vertices of our ellipse, so I'm giving you that vertice, I'm giving you this vertice, I'm giving you this vertice, I'm giving you this vertice. So, where they intersect, that is the center. So from these 2 vertices, all you got to do is take that y value, and then out of these 2 vertices, you can just take the x value, and then that's your center. You agree on that? It's another way to look at it to pull out the center. Of when you do a sketch, things kind of line up and makes more sense. But the midpoint, totally a good way to do it. But I kind of went off that, so I just took the x value off the major axis, which is 5. And then I took the y value off the minor axis endpoints, the vertices, which is -8. And that's how I pulled out the center. Midpoint is just as fun. All right. Next, let's find the distance. So let's find what a is actually equal to. And all of you, what is a equal? What's our a value? It's 12. And how did you find 12? Distance formula. Yeah, you just do the distance formula between these 2 coordinates. Now, I don't have the formula on the screen. All of you should have in your notes, like off to the side, distance formula with that written out. But the simple way to do it is to just take, in this case, 5 and 5 don't change. So we only care about the -2 and -14. So we would just do the absolute value of -2 minus -14. That's what I did. So remember, it's the entire distance, but remember, a is only half of it, so that's why we have to divide by 2. So remember, distance is always positive, whether you go, like if you traveled from your house to the store or from the store to your house, the distance is always positive no matter which direction you go. So that's why I have absolute value bars around it for distance. And I took negative 14 minus negative 2 to get negative 12. Negative 12 becomes positive 12, and then 12 over 2 gives us 6. So that's how I showed my work of finding the distance between these two endpoints. We don't have to show the extra work because 5 and 5 are the same. So hopefully you recognize that I did shorten the formula based on that fact. Okay. All right, and the same thing for the minor axis. The y values are the same, -8 and -8. So we only care the distance between 7 and 3. So again, I could do the absolute value of 7 minus 3 or the absolute value of 3 minus 7 all over 2, of course. It doesn't matter. Remember, distance is always positive no matter what you get. That's why my work shows 3 minus 7 being -4, and the absolute value of -4 is +4, and then 4 divided by 2 is 2. Because remember, A and B are the semi-major and semi-minor lengths, not the entire distance, okay? So again, A and B are half of the respective lengths. So A is 6, and again, coming over here, we already said the major axis is Y. So I probably should have come over here to my answer and put an A underneath the Y stuff, just so I don't forget. And I'm going to do it right now, but I should have done it earlier. That way I keep track of where A goes and where B goes. Because it's easy to just kind of throw those numbers in and hopefully we get it right. You got a 50-50 chance. But, based on this and we labeled stuff, it's longer in the Y direction. So the A value is 6. So we're going to have 6 squared right here. Oh, yeah. And then we already know our center. So let's go ahead and show that. And the A value we know is 6. And the B value is 2. And then we just simplify it. Final answer. So it looks like, everyone that responded, you would have gotten it right. You just got the major and minor values flip-flopped. And drawing a picture, labeling stuff like I did, putting A underneath the Y stuff to show that it is the major axis is the Y stuff. So there's your A, right? And then your minor is your under the X stuff. All right, so what do all you think about this problem? Requires some thinking. Oh yeah, yeah. So these are like puzzles. They're if you're someone who likes puzzles, you might kind of like figuring these out. They're not necessarily difficult mathematically, but they can be challenging if you're not really sure how to approach them. But that's what makes pre-calc fun. Is not every problem is done the same way, and you do actually have to think in this class. If you wanted a class where you didn't really have to think like this, consumer math actually would have been better because, well, that's more real world life stuff, calculating real life stuff versus this theoretical stuff that you will probably never use in your life unless you go into, math theory or more advanced math classes or programming. If you plan on programming, especially when you're doing like digital design and everything is tracked in 3D space. Engineering, you definitely would use this in engineering, but the computers would calculate this for you. You don't have to sit there and do this math in some type of programming lines to figure this out unless it was very specific and you actually needed to find those. But it's more advanced on programming. But yeah, engineering, something like this. So remember, in this class, you don't, you may not use this in real life, but what you are doing is you are developing the critical thinking part of your brain. Because remember, our brains aren't fully developed until what is it, like 18 to 21 years of age. So that's why it's really important to learn everything you can in these early stages in your life, because after 21 years of age, it's harder for us to learn. As a majority, some people can learn really easy up until I don't know what age, but it's hard to learn new things when you get older. That is a fact. All right, so now we have these four problems, and I promise you, these four problems are much harder than the first four problems. So number 5, I give you the center. I give you one vertex point. Check this out. I give you one vertex point, and I give you one focal point or focus point. So I don't tell you which one is the major minor axis. I don't give you two endpoints on an axis. Number 6, I give you two vertices. I don't tell you if it's major or minor vertices. I give you the foci, the two focal points, and you have to figure out everything else. Number 7, get both foci points. And I do tell you the endpoints of the major axis are these. And then number 8, I give you the foci points, and I give you endpoints of the minor axis. So you can kind of see I'm giving a little bit less information. More, you have to do more work to figure out these equations. So let's take a look. And by the way, if you have to go to other classes, feel free to take off, and you can come back and watch the recording later. Honestly, I'm gonna go as long as this takes, just because this is not during regular class time. But it has been an hour, so if you do have to step away and watch later, I understand. Sitting in a math class for more than an hour, can be like mind numbing. But let's do this. Let's take I guess we'll take like a 5-minute break so you can get up and walk around. So it has been an hour. Yeah, let's do like a 5-minute, or yeah, let's do like a 5-minute break. And if you're watching this recording, just fast forward it like about 5 minutes. But yeah, let's do a break. I need to walk around too and get another refill on my water. 5 minutes. All right. So we got these 4 problems. It's been a little over 5 minutes. So let's look at number 5. All right. So everyone back? Yes, no? Everyone back? I just got 2 people that aren't back yet, but that's okay. We'll go on. Okay, number 5. Let's look at that one. All right, I'll give you a moment, but we'll kind of start each other off on this. Given the center, we know that that's what it should be, right? That's pretty obvious. That's the center. It's given to us, and then ideas on how we can kind of approach this problem. Like notes, like just you don't have to give me specifics, but what's maybe a strategy we could do. Um, did anybody sketch stuff for this one, or I know I haven't really given you time to start it that because we had a 5-minute break. You think sketching something might be a good start? Yeah, so let's go ahead and do that. I'm just gonna put the center. So here's my center point right there, and that's -6 comma 8. And then let's plot. So I'm gonna put just a capital C here as our center. Our vertex is -11 comma 8. So let's just sketch that point. From the center, which direction should I travel? Left, right, up, or down? I should go left, and I think I agree with that. So the center is -6 comma 8. The vertex is -11 comma 8. So the y direction doesn't change. So we're not going up or down from the center to get to the vertex. We are going left and right. So from -6 to -11, we are going more negative. So we're going to go left. So I'm going to plot, just going left to our vertex. I'm just going to put a V for vertex right next to that point. All right, what about the focus point? So going back to the center, which direction should I travel to plot my focus point? I should go to the right. So from -6 to -3, it's less negative. So yeah, I agree. The focus point is going to the right. So I'm going to just go this direction, and then there is my focus point. Just put an F for focus point. Okay. And then for fun, does our graph, our ellipse, is it longer in the X or in the Y direction? How do we know it's the X direction? Or how would we know? What tells us the direction that it's longer? The focus. Yeah. So it just because it doesn't seem longer, we actually don't know the vertical distance. It doesn't tell us any it doesn't tell us any points from the center going up or down. So you can't make an assumption of it seems longer in the X direction because we actually don't know. But what Rachel says is because the focus, and she expanded, she says that because the focus point will always be on the major axis, and that is a true statement. Because the focus point is traveling left or right, that tells us that is our major axis. So we know it is longer in the x direction based on that. So I'm going to do, oops. I'm just going to do that, and then let me move it to kind of reflect what's going on here. So, definitely not accurate, but it's dun, dun, yeah, let me so I'm just gonna move some stuff around a little bit just so it looks a little better. Okay, I just moved them, spaced it so it just looks more accurate for our sketch. We have the center, we have a vertex point, and we have a focal point. And this would be a great place, to start and to look at to kind of figure things out. Rachel says, we know that A is 5 because from -6 to -11 is 5 units. So yeah, that's the center. So from -6 to -11, so from the center to this vertex, that is a distance of, you said it was 5 units. So I want to say I agree with you. Yeah, and there's my work. I use the modified distance formula between two numbers. So I didn't cover this, but this is something you probably learned in, I don't know, first or second grade about, what's the distance between two numbers? Well, it's the absolute value of one minus the other one, if you have forgotten. So I kind of just reduced our distance formula of a point and just went straight to just two numbers. So -11 to -6 is 5 units. So is our A value under the X stuff or under the Y stuff? Yeah, it's under the X stuff. And we know that based on kind of our plotting of these 3 points. And, Rachel says the focus is always in your major axis. So it's clear that it's going to be longer in the X direction based on the fact that we know the focus travels from the center to the right to get there. So that means the A value will be underneath the X stuff, which means by default, there's going to be your B value. So we already know the A value. We said it was 5. So we get 5 squared there. So the only thing we're missing is our B value. We have almost everything except that one piece. Ideas. So Rachel says we can use the focal distance to find it. And B's like, wait. Oh yeah. See, unfortunately I gave away, this was a hint, right? This was a hint. In order to solve your B value, right, we don't know what the B value is, the semi-minor axis length, but we do know what A is, right? And we can figure out what the focal distance is. Remember, focal distance is from the center to one of your foci points. By the way, foci is plural, focus is singular. I know I kind of jump in. I say focus or foci or focal. All right, so we know the A value already. What's the C value? So anybody else confirm it's 8? Rachel says it's 8. Um, so I'm going to tell you something. The distance. So look at this from your center to your vertex. Let me just label stuff, and it'll make you all think a little more than what you're doing right now. So from the vertex to there, that is your A value, right? And we know that A is equal to we said 5, right? So that means from the center to this vertex, right, to this point, this is 5 units, right? Because from the center to your two vertices, left or right, it's 5 units away. So from the center to this focal point, can that length be more than 5? It is definitely not more than 5. It can't be. It's not possible. It's less than 5. So it can't be 8. All right. Looks like we're changing our mind on this. Oops. So the distance looks like people are changing their mind to 3. So from the center, from -6 comma 8 to -3 comma 8. So remember the y value doesn't change. It's just the x direction. So from -6 to -3 is in fact 3 units. So I do agree. It is 3, and there's absolute value of -3 minus -6 is +3. And absolute value of +3 is just 3. So yeah, distance is 3. So that is your C value. So distance being 3. So that is your C value. So C equals 3. All right, now what we got to do is just plug in A and plug in C into our formula, and then we can solve for, well, the B value. That's because we need to know what B is. So here's the work. I went ahead and I solved for this, and really, actually, so I actually solved for B, but I could have left it in the form of B squared and just, so B squared is equal to A squared minus C squared. So um, I could have just found B squared to equal 16, right? And I didn't, I'm probably showing more work than I need to, because yeah, B is 4, but then I just have to put it back into the squared form, and 4 squared gives us back to 16. So I'm kind of showing more work than I need to, I think. Um, but uh, but yeah, so B is 4, and then 5 squared is 25, and then 4 squared gives us 16 for the final answer. So if you look on here, the math that we needed to actually find the equation, it's not complicated. What's complicated is identifying, like, I guess, how to approach it. But I strongly recommend to sketch out points, whether they're accurate. If you notice here, I didn't label any coordinates on my diagram. I have the center. Based on the center, the vertex has to go left. I didn't put how many. I didn't put the coordinate. I just plotted the vertex. From the center, we know the one of the focus points travels to the right. Again, I didn't put the coordinates down, but by creating a diagram and knowing the fact that the focus travels to the right, so this is our major axis, we know the ellipse is horizontal and not vertical. Then from here we can we can figure out, it's like, hey, we know from center to a vertex is your a value, so we can use the distance formula to find that, which is 5. We know the from the center to a focus point, that is your c value, that is your focal distance c. And we have the math to show that. We can use this formula to plug it in to find the missing b value. So from the center to this point, the center to this point, we are traveling up and down a total of 4 units. You can also even go to Desmos. You go to Desmos and just plot these 4 points. And really, in Desmos, it's totally accurate. And you could, if you want to sit there and count, from the center to the vertex, 1, 2, 3, 4, up to 5, and you say, oh, just by me seeing it visually and counting, it's 5 units away. So A is 5. Me counting from the center to the focus point going to the right, that's 3 units. So by graphing these, we can avoid using these equations. It's really up to you on how you want to approach it. These are puzzles. These are definitely puzzles. All right, let's look at the next one. All right, so I'm going to give all of you, I think 5 minutes on this one might be enough. So try this one, see if you can figure everything out. If you get stuck, feel free to type in chat of kind of where you're at, and maybe someone else in class can help you out. 5 minutes, and then when you are done with this problem completely and you think you have an answer, go ahead and give me the green check and we will go on, but I will give you 5 minutes. Ready, go. Just wait for one more of you. I'm going to read some of the stuff that you guys are writing in the chat. So it's like you guys are helping each other out. I really like that. So let me just scroll up. All right. Rachel says use the midpoint formula to find the vertices. Oh, I'm sorry. Use the midpoint formula for the vertices to find the center. And then you can use the distance formula between the center point and one of the vertices to find A. We know it's A because the focal points are on the same axis. Good. Making it the major axis. Then using you can use you can use the distance formula on the center point and one of the focal points to find C, and that's true. Yes. Okay, so let's take a look. All of you are done. So one of you got stuck, and that's okay. What is this? So what did you find for the center? You know, once everything is said and done, what is the coordinate of the center? 1 comma -5. So I'm just going to write that down. So the center C is 1 comma -5. So you should have gotten -1 there and then +5 here. And we're going to go through and actually how we got those. But I want to let me just check my answer real fast. Yep, so far so good. What did all of you find for your final answer? What goes here? 25. And then what goes in the other blank? 169. Let me check my answer real quick and see if that's correct. And yep, that's the exact answer that I got as well. So who got this answer correct? So about half of you got it right. The other half looks like they almost got it right. So which part did we get stuck on? So the half that didn't get it right, which part? Couldn't you figure it out? Got stuck on getting B. Okay, fair enough. Okay, let's take a look at the work. All right, again, I like plotting points, whether they don't gotta be accurate, but so we have vertices being 1 comma 8 and 1 comma -18. We can see that those points are just vertical of each other. So I'm going to have, one coordinate here and then the other one down here. One's at 8, one's at -18. The focal points are at 1 comma 7 and 1 comma -17. So we have a point here and we got a point down here. So hopefully that's kind of what you had so far. And then let me see. So I'm going to do my little ellipse Let me just move stuff around. Okay. And we're on agreement that it's vertical because, well, the focal points are in the major axis length, right? Okay. All right. So we all should have got to this point fairly quick. And hopefully you're actually writing this on paper and not trying to do it on your computer. Rachel says we could use the midpoint formula to find the center. We already know the x value. The x value is definitely going to be 1 for the center. But we have to find the point, the mid. So we got to use the midpoint formula, which is different than obviously the distance formula of that. And again, I use a slightly modified. Well, actually, I don't, because you don't have to find the mid. You don't have to show the work, the midpoint work for the x, because it's 1, right? So hopefully you didn't waste time of using the entire midpoint formula to do the x coordinate, because we already know it's 1, right? And if you did set it up, you should have still gotten 1 if you did the extra work. But we use the midpoint formula. All of you should have written down somewhere. If you don't have it memorized, it's very easy to mix up those formulas because some have plus, some have minus. So make sure you have them written down and in front of you. But here's my work. We have 8 plus -18, then divide by 2. That's for the midpoints. And that's how I got 1 comma -5, right? Okay, next. So I'm going to go ahead and just plot that point. We know the center. Oops. Just going to put that down on my little sketch here. We know that coordinate now. So then from the center to one of your vertices, that is your A value, right? And so you use the distance formula from the center to one of your vertices to find the distance. We also could have done the distance from vertex to vertex. We could have found that distance and then done what to it? Yeah, divide by 2. So there's really 2 ways we could have done this that I can see. We could use our newfound center to find that distance from center to vertex to find the A value, or we could have used the given values to find the distance from vertex to vertex and then cut that answer in half to get the A value. It really doesn't matter on how you do it because you'll get the same answer. So I did from the center. So I used our newly found center to one of our vertices. And again, it doesn't matter which one you use. So I used the coordinate that had the 8 in it. We could have used the one that had the -18. I could have had -18 minus -5, and I still would have got 13 as my answer. So the A value is 13. And I'm going to go ahead and I'll write that onto my graph. A value is 13. We also need to find the C value, right? So the C value is the distance from the center to the focal point. And we also, just like with our 2 vertices and finding your A value, you could have found that distance to give our C value, or we could have found the distance from focal point to focal point, and again, cut it in half. So there's really 2 ways to approach it, and it's really up to you. So we are going to do that. I think I used our center points, and I used one of our focal points to find our C value. And what is the C value equal to? I didn't see it in chat. 12, distance of 12. I think that's right. Yeah. So that's how I did it, and we got 12, which is our C value, right? Oh, and we also know that it's longer in the y direction, so there is our A value, which means this is our B value. And we already know the center, so we can just plug that in already. We found what A value is, so I plug that in. And then we use that formula to plug in A and C to find B, just like the last problem. And there's that work, and that's how you get 5. And then we simplify. So again, the math isn't, this math isn't complicated by any means. You just need to know how to approach it. And drawing a diagram is going to be super helpful. I wouldn't even try to attempt these without drawing some sketch like this. It really does help. All right, so we got two. We got two more, right? Yeah, we got two more. Let's keep going. All right, and again, these problems are very different than each other. So let's go ahead and finish these last two together. Let me give you 5 minutes, 4 minutes to do this one. Ready, go. In a way, I'm kind of happy I'm not teaching this during our regular time, because we definitely would not have enough time to get through these in an hour. All right, so 5 minutes, ready, go. When you finish this problem, give me a green check. It looks like everyone's done, so we will stop early for the timer. Okay. All right. What did you get for the center? Five, -4? I agree. So we all should have got x minus 5 and then x or y plus 4. Okay. Oh, I just showed the answer. Oh, I didn't mean to have it uncovered already. All right, we already know the answer. Dang it. I guess I forgot to cover that part. Whoops. Let's pretend we didn't see it. Whoopsie. Okay. Dun, dun, dun. All right. Is the a variable under the x or the y stuff? It's under the x. So let's go ahead and what does a equal to? A is 13. And then what's our b value? B is 5. All right, all right. So we already saw the answer, unfortunately, but yeah, that is correct. Let's go ahead and quickly talk about it. By the way, how did everyone do on this problem? It's like half of you got it right, the other half almost got it right, looks like. Or most of you got it right. It's more than half. All right, let's see the picture to draw. So our two focal points. So I give you the focal point, and I give you it even says endpoints of major axis. So there's no guess. So we have 17, -4, and -7, -4. So that's left and right. The y value doesn't change. So that means our graph is horizontal. So I give you two focal points, one at 17, -4, and the other one at 17, one at 17, -4, and one at -7, -4. So there's your two focal points. And then I give you the two endpoints of the major axis, which are, remember, the focus, your foci are always going to be in the major axis length. So we know that they line up. And based on the coordinates, that's going to be true. So kind of similar to the last problem. To find your center, there's two ways to do it, right? You can find the midpoints of your two focal points, or find the midpoint of your two endpoints. It doesn't matter. You get the same coordinate. So that's what we do to get the center point. And it looks like I used the focal points to find my center. And I think I did that only because they gave it to me first, no other reason. Then we find the a value by finding the distance from the center to one of your endpoints, which I used which one? I used my first coordinate. That's where I use that 18 from. So from our found center, from 5 to 18. So 18 minus 5, or 5 minus 18, it doesn't matter, but it's the absolute value, gets us 13. And then you have to find the c value. Remember, c is the focal distance. So from the center to one of your focal points, we did that, and we get 12. And just like last problem, you plug in what you're given to get the remaining, in this case, b value, and then you just plug everything in. We also know it's longer in the x direction, so the a value is going to be under the x stuff, and then our b value will be under the y stuff. The problem seems kind of easy once you saw one pretty much just like it, right? Yep. And let's look at our very last problem. Number 8. Oops. And I did not show that answer this time. Ooh. One's a little different. So this one, you're given the two foci points, and you're given the vertices of your minor axis. So a little different than in the last two for sure. Little different. So let's see if you can do this one. I would say this one's probably the hardest out of the 8 problems that we've done today. So I'll give you 5 minutes, and then, like if everyone finishes before the 5 minutes up, we will go ahead and start. Okay, everyone is finished. Let's go through this. I'll go through this one a little slower. Let me just show the answer real quick, and let's see if. Let me ask you this: is the number bigger under the X stuff or the Y stuff? All right, looks like 3 of you say the X stuff. Let me check my answer key. I agree with you. Yep, under the X stuff, it is bigger. So let me show you this answer, and then we will go through it. All right, who got this answer correct? So it looks like so far, so nobody got it correct yet. Looks like almost correct. So the middle face is you almost got it right. So something was off. Alexis, are you still here?
I'm here.
No.
I listened once.
Alexa, stop. The name is too close to hers. All right, so it looks like one of you got it correct. Okay, so let's go through this. So it looks like Alexis, she said she got it right. She was the only one, so nice job. The rest of you, something's not right. And it is possible that my answer could be wrong. Again, I typed this yesterday. It is very possible that what I have there is not the right answer. Wouldn't that be funny? Wouldn't that be funny? Okay. So let's take a look. All right, so everyone sketched these points, right? So we got 7,7 and 1,7. It looks like the y value is changing. So I'm sorry, the x value is changing. And we all agreed that it's longer in the x direction. So I'm going to go ahead and just draw an ellipse longer in the x direction because we already agreed on that. We set our 2 focal points. One's at 7,7 and one's at 1,7. So I'm just going to put my 2 focal points, just sketch it out. So here and here. It says the endpoints of the minor axis. So everyone see that? Everyone see the minor axis? So if our focal points are in the major axis always, that tells us these points without even, plotting these, this should be clear that these 2 points are not here or here. These points are definitely going to be here and here because it even says it's the minor axis. And we can see the x values don't change and the y values do change. So one's going to be at 4,11, one's going to be at 4,3. So we're going to just go ahead and plot those 2 points. One of them is here and one of them is here. All right, so based on that sketch, actually, let me ask you this. Did everyone get a sketch that was similar to this? Okay, good, good, good. All right. Can we pull out the center based on what I have here? Is it really easy to pull out the center? It is, right? So that coordinate is going to have the same y value as your focal point, and it's going to have the same x value as your given vertices. Does everyone see that? So this is the only time I'm probably going to put a coordinate here. So the x value of your center is going to be the same as your given vertices. So that's going to be a 4. And then the y value of your center will be the same y value as your given foci, which is going to be a 7. Which, based on that, obviously my answer that I typed out is not the correct answer. So I did type it wrong. Whoops. So here's what's funny is my work, I actually wrote 4,7. I wonder if this was my last problem. I wonder if I got distracted and I was like doing two things at once. And I thought, because all I did a copy paste from the previous slides just to get the formatting. And I don't think I actually finished it. Whoops, sorry. So it is 4,7. Let me, so we know that this is going to be a -4 right here, and this is going to be a -7 right there. So that's a 4. And then this is going to be a -7. All right. I wonder if that's the only thing I just forgot to type. Let's find out. All right. So what did all of you find next? So based on the information, what did you calculate next? Our b value. Yeah, we can do that first. So there's two ways to do it, right? We could get the b value by finding the distance between the given vertices and then cutting it in half, or you could find the distance from your found center to one of the vertices, right? It doesn't matter. I think what I did, I used my two given vertices. So I did a little different than the last few problems. I used the two coordinates and I found the distance between 11 and 3, and then I cut it in half. So 11 minus 3 gives me 8 divided by 2. And this should have been absolute value bars. Let me put that on there. Yeah, I didn't finish typing out the work for this one. Whoops. So yeah, it's the absolute value of 11 minus 3, which gives us 8. And 8 divided by 2 gives us 4. Okay. So that distance, so from the center to one of your vertices, this is your b value, and we found it to be 4. And we know that your in the y direction, this is going to be your b value, and in the x direction, this is going to be the a value, right? So I'm just writing an arrow. So that means we should have 4 squared written here. All right, and then how did you find the a value? There's actually, I can see 2 ways to do it. Can you? Ideas. I'm guessing all of you used this formula, right? So remember in our lesson today, in the morning and also in this one that I kind of breezed through the very beginning stuff. Let me get my line tool out here. Remember how the distance from your focal point to one of your minor vertices, what is that length equal to? Yeah, I just thought of this. Yeah, that's your A value. So this is your A value. So we could have used the distance formula. Let me rewrite that A. That looks sloppy. Okay, that looks a little better. So we could have used the distance formula of two of our coordinates. We could have used, it doesn't really matter, just choose one of them, right? We could have done this one to this coordinate, and we could have done the distance formula to find this distance, which is our A. I'm not going to do the work, but if you wanted to just kind of test that to see if that's true, it is. You'll get the same answer. You could have done that way, but I think, habits, right? It's definitely a habit that if you know two of the three, you just plug them in to solve the one that you don't have. And that would have worked. That works just as fine. Yeah, Rachel, I didn't think of it either until just now. But either way works, right? Let me just show you that work. Oh yeah, here's the equation that I used to find our C, which we found to be 3. Just the distance from the center to one of your focal points, which is what I did. I used our found center, which we said was 4 comma 7. So from 7 to I used from 7 to, I'm sorry, I used 4 to 7, not 7 to 4. I used, there's that 4 value, the X value to one of your X values from your focus. So I use this coordinate here. So from this coordinate, 7 comma 7 to your center, 4 comma 7, there's that work. And that's how you got 3. So from this point to this point here, which is 3 units. We also could have used the, we could have found the distance between these two foci, use the distance formula from this point to this point, and then just cut it in half. That also would have worked. And then once you have your your B and your C values, we just, we plug it in to find A. Or we could have used the distance formula between these 2 points. Any focus point and any minor vertice gives you your A value. And then that's how you get the answer, which is X minus 4 quantity squared over 25 plus Y minus 7 quantity squared over 16. So the A value is, in fact, 5. That is a good question. Yeah, sorry I mistyped it. I hate when I do that. All right, so that only took 2 hours and 15 minutes to get through all that. But hopefully you appreciated me spending the extra time and not rushing through it in an hour. All right, any questions before I stop the recording? My question says, if a focal point is a defining characteristic of an ellipse, how come it is nowhere in the standard form of the equation? Well, let me kind of answer that with a question for you. Let's go back to the actual formula. So it's not in the equations directly, but using the Pythagorean theorem, we can derive our C value from A and B. Because remember, A value is not only the distance from the center to a major vertice, that distance is the same distance from a focus point to a minor vertice. So technically, I could derive, or I could rewrite this equation and have C in here by just being creative with this formula. And I could replace, I could replace A squared with this entire piece. So instead of having A squared here, I would have C squared plus B squared. So I can replace this with A squared, or sorry, C squared plus B squared, which kind of makes it look more complicated. So that's, Noah, that's really the best answer I have for you. It's not in there directly, but we could derive it to rewrite these formulas and have C in there, if that makes sense. But any other questions? That was a lot of work. Yeah, these are like puzzles. So hopefully you found it enjoyable, or at least interesting. Other than that, guys, well, thanks for coming. And as always, I hope you learned something. I will see you guys all after fall break, because I will not be here the next 2 days. All right, everyone, take care.